Hello and welcome to your online regression and report writing recap session. So today what we're going to be looking at recapping the basics of multiple linear regression first. So we're going to have a go at running that on a practice data set, but then we're aiming to explore different approaches to multiple linear regression that you could use and how they're interpreted differently. So standard MLR, stepwise MLR, and hierarchical MLR. Then we're going to move on to recapping the basics of report writing and APA style and signpost you to some useful resources to support you with that. And ultimately, this is to help you to, if you're intending to use perhaps multiple linear regression in your final year research project, but in particular, if you will be doing an individual differences report which involves multiple linear regression in your second semester. So it's to get you familiar with all those sort of basics of multiple linear regression and report writing so that you're ready to go with that. Okay, so as part of the first activity, we're going to focus on regression analysis. So what I'd like you to do is to open up the online regression seminar worksheet and then the data set that goes with that. And then watch this video where I'm going to go through what the task is and then pause it and have a go at running the multiple linear regression yourself and writing up the answers to the questions there. That can just be in note form perhaps to start with. And then start the video again and watch the different approaches to conducting multiple linear regression with the same data set and how they're interpreted differently. So you can get a real sense of the strengths of and sort of limitations of the different approaches and perhaps when you might want to use them. Okay, just to outline then what the second activity is, it's around report writing. So you need to open up the report writing worksheet. Again, watch this video where I'll be outlining the task and then pause it, have a go at the activity and then watch the video again to make sure you're making any notes about the kind of the basics of report writing, things that you've perhaps forgotten or you weren't aware of the first time round. Okay, so the regression activity, the online regression seminar worksheet looks like this. So what you have is a background to a study, and it's a fictional piece of work. But the data in this fictional study was collected to explore ways of predicting stress in a sample of 300 academic staff working at a higher education institution in the UK. So a range of information has been collected, and in this, the aim of the study is to explore which of these variables is best able to predict perceived stress. So that's perceptions of stress, which is measured in this case by the total perceived stress scale score. Okay. What we want to look at is all of these variables in combination. So the fictional study, the aims of it are to explore these variables together because they've been explored in relation to stress in a sort of hodgepodge way before, perhaps only in isolation or a few variables at a time. So the aim of this is to look at it together to see whether we can predict UK academic staff perceived stress. And in particular, the researchers are interested in relationships around optimism and perceived stress and mastery and perceived stress. Okay. So in the data set, we have a variable called gender. That's a categorical variable. In this case, it only has two categories. So males have been coded as 0 and females have been coded as 1. And you should remember from your previous regression lecture and seminar that with categorical variables, knowing how they've been coded is really important when it comes to interpretation. We have a total optimism score, a total mastery score, a total positive effect and negative effect scores, life satisfaction score, and a self-esteem score. And those are our predictors, and our outcome is the total perceived stress scale score. In each case, higher scores mean more of that construct. So higher levels of optimism are reflected by higher scores on the optimism measure, and so on. Okay. So with the activity, what you need to do is, so this is quite an exploratory piece of research. What we need to do is choose an appropriate method of multiple linear regression, and that would be choosing between standard multiple linear regression, which is what you've looked at in particular, and what you had a go at running in the seminars, and stepwise multiple linear regression, which we introduced in the lecture, and hierarchical linear regression, which we introduced in the lecture, and we looked at both of those aspects of those in the paper that we sort of dissected during the lecture. So what I want you to have a go at is choosing one of those approaches. Remember, you've got all of your seminar materials, sorry, that should say week 10, not week 18, apologies. So using those seminar materials from the regression week to guide you through the steps in performing whichever of those multiple linear regressions you want to do, and then have a go at writing out the answers to the following questions in APA style. So we've got question 1 is around kind of why did you choose this method of multiple linear regression, and that's thinking in particular about the context, the design, which do you think might fit best. Question 2 is around when you've actually performed the analysis, did the data meet all of the assumptions for running that type of analysis? And when I say providing relevant evidence to support your answer, that's things like relevant statistical evidence from your output, but also relevant evidence in terms of perhaps the guides that you've used in your statistical decision making. For example, books like Julie Pallett's SPSS Survival Manual, Andy Field's Discovering Statistics book, or perhaps Tabachnik and Fiddle's Using Multivariate Statistics, and so on. Copies of those are available in the library. Question 3, was the model so overall effective in predicting stress? What we're looking at is when we look at all these variables in combination, do they allow us to predict stress scores above the rate of chance? So we are actually doing something useful by looking at these variables together. And then question 4 is around breaking it down. So if we do have a significant model, which of our predictors is contributing to that the most? So which has the strongest predictive relationship with perceived stress, and remembering that we're particularly interested in the relationships between optimism and perceived stress and mastering perceived stress. And then finally, question 5 is around, well, what are the implications of this? How can these findings be applied? What would you do with this? So trying to put your findings back into context, and that's sometimes the thing that gets forgotten. Okay. So those are the activities. I'll just show you the data set now, and then I'll ask you to pause the video to have a go at it, and then once you've done that, to start the video again, where I'll be talking through different approaches to analysis and how they're interpreted. Okay, so just to quickly show you the data set. So this is the data that you have access to. So you have a column for ID variable, so that's just the unique identifier for each person. And this is the order in which people have participated in the research. You've got a variable here, sex, which is identifying people as either female or male. So those are the only 2 categories of gender that we've recorded in this research. So if I just turn the value labels off here, you can see how they're coded. So 1 is female, 0 is male. And then we have several scale level variables, and TP stress here, total perceived stress, that's our outcome variable, and all of these others are our predictors. So have a go at running the multiple linear regression and answering those questions. Pause the video now, and then once you've done that, once you've had a go at answering those questions, start the video again and watch the different approaches that could be taken with this data. Okay, so hopefully you've now had a go at that. So you've hopefully at least written down some notes about and saved your output file so that you can have a look at the approaches that could be taken and how they are similar to what you have done. So one of the first things we want to look at is our dependent variable. So we would want to look at really how that's performing. In terms of the distribution and whether we have any outliers. So outliers are particularly a problem. There is some controversy over whether this is a required step for assumption checking with linear regression, but I'll show you how to do it. So you would go to Analyze, Descriptive Statistics, and Explore. And this is probably the quickest way of doing it. So I click on Total Perceived Stress. That's my outcome variable. I'll move that into the dependent list. And then what I'm interested in really is in the plots option. So I want histograms and I want normality plots with tests. I'll click Continue. And for now I can leave everything else as the default. So I'll click OK. So this would be a useful first step to take regardless of which type of multiple linear regression I'm going to perform. So that's why I'm going to look at it first. Now, we have quite a large sample size, so we have 300 people. For total perceived stress, we can see that we have valid data for all of those, that we've got no missing data, so that's a really good sign. We can see that the mean score is 27 points on the scale, and we can see that the trim mean is actually quite similar to that. So perhaps it's less likely that we have any really extreme outliers that are going to affect our mean. And again, the median is also very similar to the mean. That's a good sign. If you have a perfectly normal distribution, then the mean and the median should be identical. We have a standard deviation of around 7 points, so we get an idea of how dispersed the scores are around the mean. And we can see that our skew and kurtosis values are within plus and minus 1. They're not perfect, so if they were perfect, they would have scores of 0, but you never find that in practice. So in terms of these, we can see that we have perhaps a positive number here, so we might have slight positive skew. So that's where we have a tail to the right-hand side of the histogram. And we have a slight negative kurtosis, so we might have a slightly flatter distribution than would be expected if it was normal. Next, we'll look at this test of normality for the perceived stress variable. Now, because we've got a large sample size, we can choose between either the Kolmogorov-Smirnov or the Shapiro-Wilk test. So the argument is usually if you have small samples, then you should use the Shapiro-Wilk test. When you have larger samples, so that's over 50 observations, you could use either. So I'll use the Shapiro-Wilk test because it's the one I tend to use by default. And we can see here that that value is actually less than 0.05. So that is a statistically significant result. So just looking at the Shapiro-Wilk test, what we can say is that it is significantly different from a normal distribution. The problem is that tests of normality are very sensitive to sample size. So the larger your sample size, the more likely it is to just return a significant result. And what that tells us is that it's significantly different from normal, but it might not actually be substantially different from normal. So not so different that it was actually going to cause a practical problem when you run a regression. So you would have to look at this and make a decision. And you make that decision based on all the information you have. So we've already seen from the descriptive statistics, there's nothing too concerning actually in that. And I would look at my histogram to kind of clarify that. So something that will help with interpreting this distribution is to add a normal distribution curve. So I'm going to double click, bring up the chart editor, and I can add a distribution curve by clicking on this shortcut here. And by default it will fit a normal distribution curve to it. There are other types of distribution, but normal is the one that we're interested in. So I'll just click close, close again. And actually what you can see is, yes, it's not perfectly normal, but actually we've got quite a large sample size and it's roughly normal. I would look at that and I would think that there's nothing too concerning when I'm looking at in combination with my descriptive statistics. I wouldn't be too concerned about using that as my outcome variable in a multiple linear regression. But I will look at my box plots as well. You can see here actually the normal QQ plot. If these lines are perfectly aligned with the diagonal line, then it is normally distributed. And we can see there's a slight deviation in places, but it's not huge. And we can see the box plot, Our median value is here. 50% of the cases are contained within the actual box, and that's roughly equally distributed, and our tails are roughly equally distributed as well. So there are no clear outliers, and I think that looks roughly normal. So I would say that that's a tick in the box for running a multiple linear regression. So the next thing I'm going to do is actually decide which type of regression to run. In exploratory research, it's fairly typical to use a standard multiple linear regression. So that's the one I'll use first. That's the default options. So I'll go to Analyze, Regression, Linear, and it'll bring up this dialog box. So I need to select out first what is my outcome variable. So you know that's total perceived stress. I'm going to transfer that over. And in standard linear regression, you enter all predictors at the same time. So you look at them simultaneously. And I want to include everything. So I want to include gender, optimism, mastery, positive effect, negative effect, life satisfaction, and self-esteem. So I'll transfer those over. Okay, so I've sort of set up, I'm telling SPSS which variables I'm interested in for the regression. Next, I'm going to go to statistics and make sure that I get SPSS to produce everything I need in order to interpret my regression model effectively. So I need, in this case, descriptive statistics, part and partial correlations, collinearity diagnostics, and I'll choose confidence intervals as well. There's a move in APA style towards reporting confidence intervals, so I'll draw those up just in case. And because I know the order in which people have participated, I'm also going to ask for the Durbin-Watson test statistic. Now you can go into more detail around outliers. You could use the case-wise diagnostics, but for this I'm just going to use the Durbin-Watson. I'll click continue, and then the next thing I need to choose are my plots. So this is really important for checking things like normality and homoscedasticity. I'm going to talk through those in a bit. But we do that by looking at the standardized predicted values and residuals in the model and seeing if they align or if there's any kind of systematic error. We don't want systematic error. We want that error to be spread across the entire model. So we can do that by checking a plot. So we choose the standardized predictive value, which is represented by Z-pred, and put that into the x-axis, and Z-residual, that's the error, standardized error, into the y-axis. I'm going to ask it to produce all partial plots as well, because that will tell me something about the relationships between my predictors and outcome separately, and I'll also ask for a histogram and normality plot for my standardized residuals. So you don't have to go the whole hog with this, but that's what I'm going to do. I'll click continue, and I'll go to save. And what I want to do here, I could choose different types of residuals to look at, and that will be a way of identifying multivariate outliers. So if I was going to do that, I would choose the standardized probably. But here I'm actually going to look at checking for multivariate outliers by using the Mahal distance and the Cook's distance. And then I'm going to click continue, and I'm going to choose options next. So here we're not using a stepping method, but that would be important if we're looking at stepwise regression and things like that. By default, you'd usually just you would use these, so a 0.05 entry and a 0.1 alpha level removal. I want a constant included in the equation, so I'm going to leave that box ticked. Now I have complete data for everything, but if I didn't, if I had some missing data, then I'd have to choose between pairwise and listwise deletion, and you'd have to do that whatever type of regression you're running when you have missing data. Listwise means that if there's missing data for a person on just one variable, then they'll be excluded from the model completely. Pairwise means if you have missing data on one variable, you'll keep that person's data in on all the other variables in the model, but it dropped them when you're looking at the relationship between that predictor, for example, that they're missing, and the outcome variable. If they have missing data on the outcome variable, they'll just be deleted out of the whole thing. So we do have a small amount of missing data in our study. So we know that we have 300 people initially taking part, but actually there's some missing data. If you have large amounts of missing data, it becomes very problematic, and you'll need to think about how you handle it. Small amounts of missing data, you can probably choose listwise by default without too much concern, but you do have the choice. There is something called replace with the mean. It's arguably not a good thing to do. If you want to learn more about that, if you search for things like imputation and regression, missing data, then you'll come up with a whole range of literature that talks about the impact of using mean replacement. Okay, so I'll click continue, and then I'll click OK, and SPSS will produce your output. So what we have here are the descriptive statistics, and because I've used listwise, we've deleted 2 cases you can see. So we know we started with 300, but somewhere in our data set, 2 people were missing data. So they've been excluded. So we can see the means, and the mean obviously for sex, which is people's gender, in this case male and female, that doesn't really mean much to us. Okay, so we can ignore that, but we have descriptive statistics for all our scale level variables with standard deviations. So it gives you an idea of what your sample is scoring on each variable. The next box we have are the correlations, and this is really useful for a range of things. Ideally, we need to see that our outcome variable is related at least sort of moderately with each of the predictors. If we have very weak correlations between the predictors and our outcome, then we might not find much in the regression. It's not in itself a reason to not perform the regression, but it might be a sort of a warning sign. But likewise, what we're also looking for are really high correlations between our predictors, and that would be something that is a bit concerning. What is classed as a high correlation depends on really whose guidance you're following, but sometimes over 0.7, 0.8, 0.9, those are particularly concerning. So we can see, for example, that if we're looking at optimism, there's some relatively high correlations between the other predictors and optimism, but nothing too concerning. The same for total mastery, the same for positive effect, and the same for negative effect, and for total life satisfaction and total self-esteem score as well. So there are some high correlations, but perhaps not too high. And what we're looking for there is something called multicollinearity, and we can also check that using something called VIF, variance inflation values, and tolerance, and that's produced actually a little bit lower down in the output. But here we've got something called collinearity statistics, and these are the values. So if the tolerance value is less than 0.1, or the VIF value is greater than 10, you have a problem. It means that some of your variables are essentially the same thing measured twice, that they have such a high correlation that they are overlapping too much to enter into the regression. But looking at those two things in combination, we can say that there isn't anything too concerning, so we can proceed in that respect with the regression analysis. The next box tells me how my variables were entered. We can see that we only have the one model, and we use something called the enter method, and that means that everything was put in simultaneously. So that's the default method of regression, and it tends to be called standard linear regression. The next box we're interested in is the model, and we're going to look at the assumption here first before we do any interpretation of the actual model itself. What we're interested in is the Durbin-Watson, and that tells us if we have autocorrelation of error. So if there's something systematic going on in the error in the model, so the difference between predicted and observed scores for each person, that should be independent of the other person, and so on. When that's not the case, a multiple linear regression like this shouldn't be performed. And we can test that by looking at the Durbin-Watson statistic. And ideally, that value should be 2, but the closer to 2 the Durbin-Watson statistic is, the better. And we can see there that it's very close to 2, so it's not too concerning. If you have values that are under 1 or over 3, that tends to be when there's a real problem. So here we've got, as a rule of thumb, that's pretty close to 2. That's a good sign. The next assumption checking we need to perform is around our multivariate outliers. And we have 2 variables here that we could look at. We have the Mahal distance and the Cook's distance. Now what we would need to do is look at the Mahal distance and compare that to a critical value in a table based on the number of predictors that we have and so on. And we would see if our value is larger than the critical value. If it is, then we have a multivariate outlier present. So there's a table that you can look at, an abbreviated table you can look at in the Julie Pallant book, in the multiple regression chapter. And what we can see there is if you have 7 predictors, which is what we have, then the critical value for the Mahal's distance is 24.32. So we can compare ours. So that distance is smaller than the critical value expected for 7 predictors. So we don't have any multivariate outliers. But we would always follow that up by looking at the Cook's distance. So even if you do have a multivariate outlier, sometimes it's not exerting an undue influence on the model, and we can check that by looking at the Cook's distance. And if the Cook's distance is greater than 1, then the multivariate outlier is a problem and we need to do something about it. So we have at least 1 that we'll have to manage. But if that is less than 1, even if there is a multivariate outlier present, it's not actually causing a problem, so we can leave it in. Okay, so that's what we can tell from here. We're also going to look at the distribution. So we have this is an additional thing we could have. So we can see that actually the error in our model is normally distributed. That's a good sign. We have a regression plot here, and they're roughly spread out across the whole chart. There is perhaps a bit of clustering around the lower end, but there's no obvious funneling, so this is fairly rectangular. So that gives us support for normal distribution, for linearity and homoscedasticity of error. So these are all good things. For more information on checking those assumptions, I'd have a look at the Julie Pallant book and also the Andy Field book, and they talk through some of this in more detail. So in all, we've looked at a whole range of different assumptions. There's one important one that we haven't sort of considered, and that's sample size. So there are lots of different ways of calculating sample size. Tabachnik and Fiddle provide different models you can use to predict, to identify the right number of participants based on the number of predictors in a model and so on. Julie Pallant also provides some rules of thumb. A very rough rule of thumb is that you have to have at least 15 participants per predictor in the model. That's a very rough rule of thumb, and that's for standard linear regression. For stepwise linear regression, the very rough rule of thumb is 40 participants per predictor. So if we had, so we know we've got 7 predictors, so that would lead us to need at least, if that's 15 people per predictor, at least 105. So we can see that we have, we're above that. But there are more refined ways of calculating sample size, and actually Andy Field has a really good chapter, a section on this in his book, in his regression chapter, and there are 3 charts he uses that you can use to identify an appropriate number of participants per for every type of regression that you're doing. Okay, but all in all, those are good signs. We know that our predictors are either scale level or dichotomous, which is required by multiple linear regression, and our outcome is scale level, again, which is required. So actually, from all of that, I would say that it is appropriate to perform this type of analysis, and that we can now actually interpret the model. So to judge whether the model is effective at all in predicting perceived stress, we'll first look at the model summary table. This provides us with a range of useful information, in particular the R-square value and the adjusted R-square value. So the R-square value can be multiplied by 100, and that tells us the percentage of variance accounted for in total perceived stress by the predictors. And so we can see here that that's basically 65%. So 65% of the variance in perceived stress can be explained by knowing people's self-esteem, negative and positive effect, life satisfaction, mastery and optimism. So that sounds like quite a large percentage of variance. That's a good thing to know. The adjusted R-squared tends to be slightly more robust, so if you want to make generalizations beyond the sample, it's arguably the better one to use. And we can see that there's only a slight drop in the percentage of variance explained based on this, which is 64%. So that's still a very useful amount of variance to be able to predict in terms of total perceived stress. But we don't know if that's actually statistically significant. So the next thing we need to look at is our ANOVA table here. We're looking at the significance value, and if that is less than 0.05, then it is statistically significant. And we can see that, yeah, that value is less than 0.05. So we know that our model is statistically significant. It is significantly better than essentially guessing perceived stress. So actually looking at these variables in combination tells us something useful about perceived stress. It allows us to make useful predictions. Okay, so that warrants looking at the individual predictors in the model and thinking about what they might mean. So one of the first things we might be interested in doing is identifying which variable is the strongest predictor. And we can do that by looking at the standardized coefficients, the beta coefficients. And this is because they are standardized, so we can compare them. The unstandardized coefficients are in the original units of measurement, and you can't directly compare between them. So that's what we're going to look at, and we're looking for the largest value. So whichever is the largest value, that's our strongest predictor. And you'll also see it reflected actually in your t-value as well. So what we can see here is that the largest predictor is total negative effect. So that looks like our strongest predictor, which is followed quite closely, next by mastery scores, life satisfaction, and then gender, and then optimism. So we can see that's the sort of the strength of the relationships between, in the order between predictors and outcome, but we'll need to look at whether that's statistically significant. So we can see that sex is statistically significant, mastery, negative effect, life satisfaction and self-esteem are all statistically significant, but actually optimism and positive effect are not. So that tells us something quite interesting. So if we're thinking back to the context, what does this suggest? Well, there's something perhaps about knowing people's negative effect and their mastery and life satisfaction that will be useful to understand, in particular, to understand perceived stress. But actually, if we were thinking about the context, we were interested in optimism and mastery in particular. Well, there doesn't appear to be a relationship between optimism and our outcome variable, but there is between mastery. So what do those relationships look like? So we'll just pick out a few. We'll look at the strongest predictor, sorry. So total negative effect, what we can see here is that's a positive number. So as your score on total negative effect increases, your total perceived stress score will also increase. And if we look at the unstandardized coefficients, we can say that for every unit of negative effect you increase by, your perceived stress score will go up by 0.3 of a point. So that gives us a sense of the scale of the relationship. So we'll look now at total mastery score, and we can see that that has a negative relationship. So as your mastery score increases, your score on perceived stress will decrease. So what we can see there is that for every unit of you increase on mastery, your score will, on perceived stress will decrease by 0.39 of a point. Okay. So we'll look at one last one, life satisfaction. So as your life satisfaction decreases, your perceived stress score will increase by 0.17. So, sorry, to say that a different way, as your life satisfaction score unit increases, perceived stress score decreases by 0.17 of a point on perceived stress. So there are others in there, but I won't go any further with those. But I will look at the sex variable. So we know that females were scored coded as 1 and males were scored coded as 0. So what we can see here is there is a significant difference between males and females on perceived stress. That's a positive number. So anything that was coded as 1, which was females, scores higher than anything that was coded as 0. So females have higher perceived stress scores than males. In fact, they have 1.2 points higher on the perceived stress scale score compared to males. So when you're reporting this, you'd want to report those things. You might want to report your confidence intervals here as well. And you might want to report things like your part correlations. Now you can do that fairly easily when you have used something like listwise deletion. And what you do is you square that and times it by 100, and it would tell you the unique percentage of variance accounted for by that variable. So holding all these other variables constant, how much variance does that variable account for? So if we have a look at, for example, negative effect, we look at the part correlation there. We have a correlation of 0.310. We times that by itself, so we square it, 0.310, and then we times that by 100, and that accounts for about 9.6% of the variance uniquely in perceived stress score. So there's more you can pull out of a regression. Okay, so just pause the video now and have a look at, is that the approach that you took? Did we pull out the similar sorts of findings or draw the same sorts of conclusions around assumption checking, around interpretation of the model? And do you have any queries about how that should be reported? So having a look at reporting it in APA style, have a look back at your regression seminar activities from week 10. And if you have any further questions, then post those to the discussion forum in the general inquiries discussion forum. Post them there. But pause the video and then I'll take you through some alternatives. Okay, so hopefully you've had a look at that as well. So the next thing I'm going to show you are the two different approaches. Now, I'm not going to go through all the same assumption checking. A lot of the things are essentially the same. If you're choosing to do either a standardized or a hierarchical regression, but I'm just going to show you what they look like and how you would interpret them so you get a sense of when they might be used. So in exploratory research, another common approach to multiple linear regression is something called stepwise. So we would go to analyze, go to regression, go to linear, and all of the options that we chose from before are here. but we'll need to choose a few more. So the first thing we need to do is to choose the method, and we want stepwise. Now there are different types of stepwise, but I'm just going to use stepwise. Okay. There are different ones. If you want to learn the difference between those, have a look at Andy Field's discussion, Discovering Statistics Using SPSS book. So then in statistics, I need to ask for something additional. I need to find out the R-squared change. That's really important. So I'll click continue, and then everything else we can leave as it was, and I'll just run again. As I said, all of this initial output where we're checking assumptions is going to remain the same, so we can just skip through that. What's different is here. So what we have here are variables entered and removed. We can see that in each block what's been entered, what's been removed. So here what we're doing, you can see it called stepwise. We can see that we've used the default options of when to enter and remove variables. And we can see that the dependent variable is perceived stress. So what we've actually got in comparison to the first multiple linear regression we ran are 5 models. So we can have a look at what they do. So we can see that the Durbin-Watson's only produced for the final step in the model. So the final step is the one that SPSS, based on the criteria we've used here, the default criteria, has selected out the ideal model. What is the best combination of predictors in relation to perceived stress? So what it has done is looked at mathematically the most economic way of predicting perceived stress, but it's sort of taking all of our thinking out of the question, and that's why stepwise can be controversial. What we can see here then is that the first model was able to account for 45% of the variance in scores on perceived stress, and we can see that the first model included something called the constant and then total negative effect. So we know from the original regression we ran that was the strongest predictor, and that's actually why SPSS has chosen this one and entered it first. So what we have here is that just by that model we can predict 45% of the variance in perceived stress. The next model, it's found that total mastery, adding that variable to the model, now accounts for 58% of the variance in perceived stress. The third model, 62% of the variance, and that includes total negative effect, mastery and life satisfaction. The fourth model, 64%, and that's negative effect, mastery, total life satisfaction and self-esteem. And the fifth model has included sex as well, and that's 65% of the variance. So we can see how it's built it up, and the fifth model is where it's stopped. And what we can see is something called here the F change. So in the initial model we can see that that was statistically significant, but what this tells us is by adding any additional variables in to our model, does that add something worthwhile? Is the amount of variance that it can additionally predict based on including that, is that statistically significant? Is there a statistically significant change in the amount of variance accounted for? We know it's going up, but is that by a statistically significant amount each time? So what we're doing is saying if that value is less than 0.05 or less, then it is statistically significant. And we can actually see incrementally that every time we've added those predictors in, it has been statistically significant. So it is explaining significantly more amounts of variance in addition to what we could explain before. So we've got here a final model that is statistically significant increase in the amount of variance accounted for. So we look then to say, but is the final model overall statistically significant? So we've got 5 steps, 5 models. We're looking at the final one here, and we can see that yes, it is. So that model is statistically significant. And then finally we're looking at our excluded variables, So we can see actually in the final model, it has kicked out the two variables that we had identified as non-significant, which was optimism and positive effect. So it's kind of confirmed almost what our initial interpretation was when we used the standard multiple linear regression. But you should always check, see what's been excluded at each step. And then we will probably interpret only the final model, but you will report everything. So actually reporting stepwise can be quite a challenge, but it's useful because you can see how the relationships between predictors change as soon as you start to control for other variables. So you can see originally total negative effect had an unstandardized coefficient of 0.556, but in the second model, where we also included mastery, that's decreased to 0.377. That's the unique amount of variance, the unique relationship accounted for. So there's some overlap between these variables. So that's why you would report every step in the model, but you'd probably focus your energies on interpreting this final one. And that's how you would really report it. So everything else that in the output is the same as the original standard multiple linear regression we performed. So I'm just going to show you how you could run the other type of regression, and that is hierarchical. Now in this case, usually hierarchical is used when you want to test a specific theory or you want to control for something. So you want to look at the variance that's accounted for whilst you know that there's another variable that's going to take priority, but you're not really interested in that one, for example. Or you know the order of the importance of things based on theory. But in this case, it might not be the best fit, but we know that we were particularly interested in mastery and optimism to start with. So what we might actually do is choose to look at that first and then see what's added by looking at the other variables. So you could look at that first, and you could do that by hierarchical regression. So I'm just going to use this to demonstrate it really. So regression, linear again. So we're leaving all of these things. This was our default options, but what I'm actually going to do is put that back to enter so that it will add in each block the variables simultaneously. I'm going to actually put these back across. What I'm going to do is say I want to look at optimism and mastery first, and then in my next block I'm going to take everything else. Oops, I don't want them a half distance there. And I'm going to leave everything else, all the default options as they were. I'm going to click OK. And this is what it will produce. So the descriptive statistics and correlations box will stay the same. There's a slight change to the Durbin-Watson, but again, that's not problematic. And what we can see here is we have two models. So the first part of the model has only mastery and optimism included, and then the second model has those variables plus all the other predictors included. And that's what we've specified. We can see that there is a significant initial model, and that adding the rest of our predictors to mastery and optimism has led to an increase in the significant increase in the amount of variance explained. So it would appear worthwhile. So the next thing we can see is, well, both steps of that model are statistically significant. And if we look at the original model, then optimism is statistically significant and mastery is statistically significant. But when we actually then combine everything else, what we can see is that optimism stops being statistically significant, although mastery remains statistically significant. So what this suggests is that there is something that optimism is related, but actually there's a certain amount of overlap with the other variables, so that when you account for those, its unique ability to predict perceived stress reduces. So that in itself is useful. So we know that actually it may be more parsimonious to look at mastery and some of these other variables rather than optimism and so on, because optimism doesn't uniquely explain the relationship between with perceived stress, but some of these other variables do. So that's, again, you would report each of the steps in that, and you would probably concentrate on, you would look at the change. That would be an important thing to draw out in your interpretation. But you report both steps and you'd interpret what they mean. Again, the rest of the output remains the same. So that's how you might draw out some of the key things with regression. So we've recapped the different types of regression, when you might use them, what they could tell you, how they go about it in different ways. We've also broken down assumption checking. We have looked at how you identify whether a model is effective overall in predicting an outcome variable. And then we've broken that down by individual predictors and how we can tell what the individual relationships, predictive relationships between each variable and outcome variable are. So hopefully that's been useful to recap. Remember that you've got this to look back to. It'll be a different scenario in your individual differences assignment, but remember you have got this you can look back on, and then have a go at activity 2 in a bit. Thank you.